In this video, we're going to talk about the Bohr model of an atom. And it is so important that you understand this concept to understand kind of what each element looks like, where electrons are. So please make sure that you take your time understanding your Bohr models of the atom, okay? And please make sure you understand Bohr models before going to electron configuration. So there is a long history of atomic structure changing what we understand about atomic structure, going from like a solid sphere to a plum pudding model to the nuclear model to now what we kind of consider as the main model is the electron cloud model, right? Electron cloud is the model that we use now and in our best understanding of what an atom looks like. But if you're talking about an electron cloud, just attempt to draw this. So here's your nucleus, right? And then what the electron cloud says is basically there's just a probability of like where your electron might be located around that nucleus. So, you know, you're going to have a higher probability here, closer to the nucleus, but not too close. You're going to get this like weird, you know, probability of where your electrons are, which is more accurate for kind of in reality where electrons are, but for our sake in understanding kind of where electrons are, what the heck to do with them, how electrons are involved in bonding, we are going to use the Bohr model. So the Bohr model is going to simplify our understanding of where electrons are. And this is a really good thing because understanding where electrons are, this will help us figure out bonding, okay? Because all bonding deals with either a transfer or a sharing of electrons, which we'll talk about in our next chapter. But we have to understand where electrons are. That way we can get into chemical bonding, okay? Bohr is just a very brilliant guy, and we can use the periodic table to help us understand Bohr models, okay? So really important that you understand your period numbers that are written right here, 1, 2, 3, 4, 5, 6, 7, all the way down, and your group numbers that are written across, okay? So I'm kind of compacting the periodic table because I want us to be able to really see how these Bohr models are laid out, okay? All right, so you can see I kind of smushed this together to make everything bigger, so just so you understand. All right, so basic idea is that your periods of the periodic table, as you go across the periodic table, what your periods tell you is how many electron shells an element has. 1, 2, 3, 4, 5, etc. are telling you how many electron shells you have, okay? So something on the first period of the periodic table only has one shell, one electron shell. Let's draw it out. We'll do green for the nucleus every time, okay? So here's my nucleus, and I'm going to have one electron shell, okay? One electron shell that electrons are going to be orbiting around. I then go over to helium. It has a nucleus, and it's on the first period, so it has, again, one electron shell. Okay, then I get kicked down to the second period of the periodic table. I have a nucleus, but now I have 2 electron shells. 1, 2 electron shells. So my electrons are not only just on the first shell, but now electrons go out to that second shell. All right, same thing here with beryllium. 1, 2 shells. Okay, and it would be the same thing all the way across for my second period. Okay, I'm not going to draw every single one because that would be too much. Okay, but you get it. So anything on that second period is going to have 1, 2 shells. 1, 2 shells. Okay, I guess we'll draw neon. Neon will be right here. The noble gas has 1, 2 shells, and you can see what's going to happen next, right? After neon, after element number 10, there's nothing else here. It gets kicked down to period 3. And on period 3, I'm going to have 3 electron shells, right? 1, 2, hopefully this fits, 3, okay? And that goes all the way across for the third period. If I'm somewhere on the fifth period, okay, I'll draw it over here just so I have space. I'm gonna have 1, 2, 3, drawing a bunch of circles is terrible, 4, oh my goodness, and 5, oof, 5 electron shells, okay? Hopefully this concept makes sense. As you go down the periodic table, okay, each period tells us how many electron shells that element has, okay? Okay, so the period tells you how many electron shells you're dealing with. Then as you count across, it will tell you how many electrons go on each shell. Okay, so counting across with your groups, let's pick a different color here. Okay, so counting across tells you how many electrons go on each shell, all right? Now, it gets a little bit wonky here in the middle with your transition metals and your inner transition metals. And we will talk more about this in chapters 4 and chapter 5, okay? So for simplicity's sake for now, the way that I want you to think about this, when you count across, count 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, so if I was actually looking at the periodic table, okay, this guy would be 1, 1A, 2, and then you're gonna go just 2, kind of skip over this, pretend like all of these are just 2. Again, I promise we'll talk more about transition metals in a little bit, but 1, 2, then you're here at 3B, right? So 3, 4, 5, 6, 7, and 8, okay? These numbers, these Roman numerals up top tell you how many electrons go in that shell, okay? And let's actually do it, all right? So right here, my very first one is hydrogen, okay? Hydrogen is on my first period, so he has 1 shell, and he's in my first column, my first group, so he has 1 electron on that 1 shell. Boop. That's the Bohr model of hydrogen, okay? I've got my nucleus, I have 1 shell, and 1 electron on that 1 shell. Okay, now if I go across, helium right here is the only weirdo, right? Because there's nothing in between hydrogen and helium, right? So here we go, hydrogen, nothing here, and then I hit helium, right? I don't hit any other elements along the way. So helium is technically number 2 in shell 1, right? 1, 2. Helium is the only weirdo that kind of breaks this rule. Okay, so I go 1 and over to helium is going to be 2. So, right, this could be 8 or 2 if it's helium. Okay, so helium is on my first period, so 1 electron shell, and he's the second one. He's the second element in that period, so he has 1, 2 electrons on that first shell. Okay, then I get kicked down to my second shell, right? My second period. And this guy, lithium, if you're following along on your periodic table, right? This is lithium, all right? Lithium has that first shell filled, right? That first shell is still filled. So he should have 1, 2 electrons on that first shell. And then he got kicked down to his second shell. And on that second shell, he has 1 electron because he's in the first column for that second period, okay? So 1 electron goes in the second shell. Boom, just like that, okay? Next would be beryllium. Beryllium has that inner shell filled, so 1, 2 for shell number 1. And then he has 1, 2 in shell number 2 because he's on the second column of shell number 2. 1, 2. Okay, that's beryllium. We keep going over. Here's boron, right? So he's on that second period and he is 1, 2, 3 over. So he should have 1, 2, 3 electrons on his second shell, and his inner shell is also filled. Okay. I skipped a bunch and we get to oxygen, right? Oxygen is right here in column 6. Column 6 is oxygen. Okay. Again, inner shell is filled. And you can see that he's in column 6, so you could just put 6 on a second shell, or you could count, right? So here's my second shell, and then I count across. So in my second shell, I have 1, 2, 3, 4, 5, 6 electrons on that second shell. So 1, 2, 3, 4, 5, and 6. And last but not least, on this column, here's neon. Okay, I skipped fluorine, went to neon. All right, just otherwise it's going to take up too much space. All right, so again, that first shell is filled, 1, 2. And this second shell is now going to be full at 8. Right, on my second shell, I have 1, 2, 3, 4, 5, 6, 7, 8 to get to neon right here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons on that second shell. And now I'm all full up on this second shell. There's no other electrons that are going to fit on that second shell, which is why I get kicked down to shell number 3. Okay? So same thing with shell number 3. My inner shell, my shell number 1 is full with 1, 2. Right? 1, 2 on shell 1. My second shell is full with 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh my God, how many times can your teacher count to 8? Okay. And then I'm on my third shell now. And on my third shell, I'm in my first column. So I should only have 1 electron on that third shell for sodium. Okay. And you can build this out forever. All right. So for here, we'll say that's the 5th column on shell 3. So we're looking at phosphorus right here. Okay. So right here, 1, 2 on my first shell, 8 on my second shell, and then counting across to get here to phosphorus would be 1, 2, 3, 4, 5. So this should have 5 electrons on my third shell, right? On the third period. 1, 2, 3, 4, 5. All right. You get the idea, hopefully. All right. So you can literally look at any element on the periodic table. Okay. And we'll just kind of ignore for right now. We'll ignore these guys. Ignore your transition metals and your inner transition metals. Okay. But for these guys right here, and these guys right here, okay, you should be able to look at it and figure out exactly how many electrons go in exactly which shell, all right? And the only reason that these ones are nice little weirdos, we'll talk more about electron configuration to figure them out, all right? But, okay, what I would like you to do, I'm going to give you some practice problems, okay? I'll give you one random example, okay? I'll do magnesium, all right? So you can see what it looks like. And then what I want you to do after that is pause to make sure you can do all of these Bohr models, okay? So if I'm looking at magnesium, here he is, right? So first thing I do is figure out what period he's on. He's on the 1, 2, 3. He's on the third period, which means I know right away magnesium is going to have 3 electron shells. 1, 2, 3. Okay, so I have the correct number of shells for magnesium. Now I need to figure out how many electrons go on each shell. So in shell 1, I have 1, 2 electrons. On shell 2, on period 2, I have 1, 2, 3, 4, 5, 6, 7, 8. And then on shell 3, where magnesium is, I should have 1, 2 electrons on that third shell to get to magnesium. 1, 2. So shell 3 should have 1, 2 electrons on it. Okay, that's your Bohr model for magnesium. All right, so for hydrogen, helium, silicon, fluorine, chlorine, let's add in neon just so you have a noble gas. Okay, another noble gas. All right, I want you to pause the video and try to do Bohr models for these elements. and then we'll come back and make sure you got the right answers, okay? So pause. Okay, so this should be your answer, right? Hydrogen should have one shell with one electron on that shell. Helium has one shell with two electrons on that shell. Silicon should have 1, 2, 3 shells. Both inner shells should be filled. So first shell has 2, second shell has 8, and then your third shell should have 4 for silicon, right? So here's silicon. You should have 1, 2, 3, 4 electrons on that third period, on that third shell, okay? Fluorine, first shell has 2, second shell has 7. Magnesium we already did. Neon, first shell has 2, second shell has 8. And finally, chlorine should go 2, 8, and then 7. All right? So these are Bohr models. Hooray.